Hello, seventh grade. Welcome back to the end of Activity 97. Today we're going to go over your analysis questions, numbers 1 to 3. As you have your notebook with you, make sure that you are checking your answers. I had a student ask me, do I have to write this down? Can I just go over it? And I guess the answer to that question is that obviously I can't see if you're writing the answers down. But, when you get to do graded work, you get to have your notebook and you can use that information later. So I really still would like you to write things down and treat it just like we would a normal school day as much as possible. I really do think it'll make a difference for you if you are taking notes and writing things down so that when you try to do an assignment, you can make little notes in your margins, or if you're doing something graded, you can look back on the things that we did in your notes. So that's just my feedback on terms of keeping a good science notebook as we are doing this from home. Okay, so analysis question number 1 was, are mutations always helpful? Explain. You were probably noticing that we keep having similar questions about mutations. They're really important, and the mutations are, natural selection can't happen without the mutations, so they are so helpful. So when you did this one, you should have come up with an answer that said that mutations are not always helpful. Some mutations are neither harmful or helpful. Most of the mutations that happen on any given situation are neither, and they neither make the animal better suited or less suited to their environment. And then on top of that, when you get a mutation, whether it's helpful or not is really going to depend on its environment. So I can't stress that enough. This sentence right here is really, really important. And it's important that you recognize, and I'm trying to see, I can't highlight this way, but it's really, really important that you recognize that, when an animal or an organism has a mutation, to figure out if it's helpful or harmful or not really is going to depend on where they live and what's going on in their environment. So that's super, super important. But in general, if a mutation becomes common in a population, if we start seeing something new and that new whatever trait starts showing up more and more and more, it had to be helpful or advantageous in some way for that population. So that's kind of how scientists sometimes recognize that natural selection is happening when a new trait starts spreading through a given population. Okay. Analysis question number 2 was, how can mutations enable the evolution of a new species to occur? And it told you to use the story of the cichlids to help you explain your ideas. So I'm going to do 2 things here. I'm trying something new and I'm hoping that it works. Normally for this in class, I would draw on the board. You know how I love to draw you the picture. So I would try and draw that for you so that you could actually see the explanation. So I'm going to do it 2 ways for you. I tried to make a video that I'm going to show you. I made it with my phone and tried to make it work that way. And I'm going to try and show it to you so you could see how I would have explained it to you visually on the board. And then after that, I will go back to the PowerPoint and I will show you the Word version so that you can take notes. But this is kind of a cool way of doing it. Okay, so let's say we have Lake Victoria. Okay, see that? Let's see. Oh, right there. Okay, and so here's your water. And within the lake, there are a couple different ecosystems. So our original fish that lived in the lake are these purple fish. Okay, so these are the original fish. Okay, And they are doing fine until all of a sudden these two fish reproduce, and this fish makes a fish that has a mutation that allows it to be different. Okay, so we're going to give them a different color. So this fish, we find out, is able to live in the cold. And so he starts going to the bottom of the water to live. And what he finds out in the bottom of the water is that there's more food and he's more successful. And so originally he'll come back up to the top to be with his family, but over time he realizes that he's going to do better at the bottom. So he or she will start laying eggs. Maybe they go back and reproduce with the original OG fish. And then they come down and they start passing on the traits for those cold water genes. Okay, so now we have our original fish up top and the cold water fish down below. Now that there's more than one cold water fish down here, they stop going back up to the top and they stop reproducing. So these together, they stop reproducing together. The original fish continue to reproduce with each other and share their traits, and they continue. And then the cold water fish stay down below where it's cold, and they are better suited to the food and the temperature at the bottom of the lake. Now, eventually, other mutations are going to occur. So maybe the purple fish accumulates some other mutations, and the green fish, the cold water fish, also make new mutations. And so eventually, let's say one of these fish gets a little curious, and so he swims up to the top. And he falls in love with, hypothetically, with one of the purple fish. But when they try to reproduce, it does not work. So these two can no longer reproduce because the cold water fish, their genes are so much different from the purple, the original fish, that they can no longer make a baby. And when that happens, what do we call that? That is speciation. It means that this fish is a different species from this fish. Their DNA is too different and they can no longer interbreed successfully with each other. Okay, so this is just the written version of what I just showed you in the drawing version. So you have to realize that in a lake, there are lots of different ecosystems in there based on the amount of sunlight and the types of food and the insects and the predators, and it's kind of sectioned off. And so if that cichlid is born with one single mutation that allows it to go deeper in the water where the water's colder, then they would be more successful and they would have more food that the other fish didn't have. And so really over time, you get to that point where you have DNA that no longer matches, and that's when we say speciation has occurred. So I think that's a really good question, and I thought that the cichlid example is a really good way of going back to examine that. Okay, number 3 is my favorite question. So number 3 talks about bacteria, and it talks about the idea that bacteria reproduce very quickly. It says they have a generation time of about 20 minutes. Humans have a generation time of about 20 years, which just means that humans typically don't have children until they are past 20. Whereas bacteria, every 20 minutes they reproduce. So just to give you an idea, you pick up one bacteria in your body. In 20 minutes there are 2 bacteria. In 40 minutes you now have 4 bacteria because they double. And then in an hour you have 8, then 16, then 32, 64, just like that. So that's why you get pretty sick pretty quickly when you have a bacterial infection, something like strep throat or an ear infection. So the question asks you, would you expect humans or bacteria to evolve faster and why? So this is a great question. Um, the answer is that bacteria have to evolve faster because their populations reproduce faster. So remember, mutations occur when offsprings are formed. If the bacteria are forming more offspring, just in general, and faster, then they have more opportunity to evolve because they can mutate and become more successful in different environments. So we call this something really cool. We call this antibiotic resistance. Also, really important, and it's a cool idea, and it's something that I wouldn't mind taking a little bit to talk about. So let's talk about, you've probably heard antibiotic resistance. And it used to be when you went to the doctor, they would give you an antibiotic for anything. But now when you go, a lot of times, probably when your parents take you to the doctors, you're told a lot of times, like, let's wait and see how he feels in a few days, or let's see what happens. And a lot of that has to do with antibiotic resistance. So antibiotics are medicines used to kill bacteria. They don't work on viruses. If you have the flu, antibiotics aren't going to help you. So it has to be something that's bacterial in nature. When you get your prescription, it's usually for 10 days. The doctor wants to make sure that you kill all of the bacteria in your system. So when you start taking your medicine after like a day or two, you start feeling better because you kill enough bacteria that a lot of your symptoms go away. But it's really important that you kill them all, because what ends up happening is you may have one or two bacteria in there that when they replicated, they mutated and they became more successful in the environment with that antibiotic. So let's say it's penicillin. Let's say you're taking penicillin and most of the bacteria die, but some of them are resistant to penicillin, so they stay in there. And then when you quit taking your medicine, you start getting sick again. And that's because your bacteria in your system have evolved and they've outsmarted the medicine. Okay? They're resistant and the medicine doesn't work on them. Here's a visual to explain that. Okay? So here's your bacteria. The normal ones are the blue. Here's your mutated resistant bacteria. So when you take your medicine, it kills off all of the regular bacteria. But look what this guy does. The resistant bacteria keeps replicating. And so even though you've taken all of your medicine, by the end, you still have all of these bacteria in your system. And that sometimes is scary. So if you have something that's resistant to a lot of different types of medicine, it's harder to kill those. And those are the ones that can be scary. So doctors have kind of backed off on prescribing as many antibiotics because we were, as a society, we were having a lot more of these infections that were harder to kill. So I found a cool video that I really want you to click on, so you'll see it in the links below. It's okay to be smart video. It's called Rise of the Superbugs. So I really want you to watch it. So after you watch that video, I want you to go into your classwork feed in the Google Classroom, and I want you to take the Activity 97 exit ticket. It's true and false questions. There's 8 of them, and it is going to be a grade. So I want you to try your best. If you are not sure about a question or you need some extra help, send me a message and we can chat about it and try and figure it out so that you can get the best grade that you can. And guys, I can't stress enough, I've said it a couple times this week, if you need help, you have to ask, and I would love to help you. Whether it's chatting on Hangouts or if it's setting up a tutoring session with Google Meets, we can do that. But you have to let me know so that I can help you. Okay? So go ahead and watch The Rise of the Superbugs and take your exit ticket and have a great weekend. And I'll catch you next week. Bye, guys.